Okay, we're Thursday of week 4, and we're starting with turn-in homework questions. We're going to eventually do some from both the typicality and the bell curves, but we're actually going to start with the typicality. So a shipping company needs to transport 7 things. Those are their weights. What are the mean and the median? So for the mean, you're going to find the sum and divide by how many. So if I add them all up, I did find which of my children had stolen my calculator the other day. I'm getting 214. Is that what people who have done this also got? So I don't have any calculator typos. For the median, I list them in order, which they are, and then I pick the middle one. So on one side, I kind of had 3. On the other side, 1, 2, 3, and 18 is in the middle. Everyone okay with that one? Okay, the more interesting part is number 8. So somebody gets a report, and the report only says mean, whatever it was, 30.6. Median, and 18. And also the report says that there's 7 containers. So one clerk says there's 7 containers. A typical weight is 30. So let's do 7 times 30.6. The other clerk says there's 7 containers. A typical weight is 18. So let's do 7 times 18. So the actual total was the 214. It's not surprising that if you multiply by the mean, you get back to the total, because dividing by 7 was how we got from the total. So if we multiply by 7, we get back there. The times 7 and divide by 7 cancel each other out. If I took the median and multiplied it by 7, that doesn't actually help. This one crate that weighs so much is kind of skipped over by the median. It doesn't matter whether it's 77 or 177 or 61. It's just the biggest value. By picking the middle, we're neglecting it, saying it's not really representative. And for certain things like housing prices or incomes in the city, then yeah, we don't care about the very biggest and very smallest thing. But it does mean you can't go backwards. If we try a times 7, we're going to get some nonsense number. How much is it off by? Going to be 88 tons off. Okay, questions about 7 or 8? Okay, 9 and 10 were written a little funny, and in the grading, more than one bubble can be correct, so don't worry about picking the very best thing. But the answers are a little bit, they're all things that sound nice, so what's happening here? For number 9, some news articles make a big deal when countries have an average temperature increase that's well above the global average. So I gave you a whole bunch of links you don't have to follow, but if you did, then you'd say, oh look, this country has warming that's faster than average, right? So why is that true? Let's go here. Is that not surprising because countries are different in many ways? Well, they are, but that might not be the best answer. There's no such thing as a typical country. That's also sort of a reasonable thing to say, but maybe that's not the best answer. We would expect any histogram to have some items above average. That's also true, right? If we have a histogram, then there's always going to be some things above average and some things below average. The items above average this year might be below average next year. It's not necessarily true that just because you're above middle on a histogram that promises anything as a long-term trend. So which of these 4 reasonable things do you think is the best one if we had to pick only one? And Timothy is muted still, but I hear him talking.
I would say there's no such thing as no typical country, or the typical country one.
I would say the third answer.
Oh, okay. Yeah, I think the one that I like best myself is the third one. If you're claiming something is above average when you make a histogram, then yeah, there's going to be something above average, right? All these different types of histograms have some things above average. So the fact that there are some countries whose rate of increase is above the average rate of increase, and of course, they're not all the same. You could make other stories about some are having below average, but that wouldn't be as exciting. But it's not that the other answers are bad. For the last one, then was a strike in 2007, and according to one report, the Writers Guild has 4,434 writers who worked full-time, and their average salary was $204,000. That makes them sound like, why are they going on strike? They're making lots of money. Another headline said that the median income was $5,000 a year. That sounds like maybe they do need to go on strike. They're not making much at all. So what happened was, if you have the histogram for this situation, then maybe the first bin is we're not earning anything, and the second bin is we're earning only 1,000, and so on. I'm not going to bother to label these, but imagine way out on the side, you have earn lots. So, 2 important facts. First, almost half the Guild's writers don't write anything in a given year. Just because you've written for a TV show or movie once doesn't mean that you're actually doing it this year also. So this bar for the zeros contains half of everything. All the other bars are just going to add up to the same height as that bar. And second, a very few writers will earn millions of dollars. If you wrote the screenplay to the big blockbuster best-selling movie, then you get paid a lot. So there's going to be a few people that are just way out on the left side, and there might not even be very many of them at all. And then all the other bars are somewhere in the middle. Maybe some people earn just a little, and some people earn a little here, right? Whatever it is. So the news article that talked about the average, the mean, when you add them up and divide by how many, these incredibly million-dollar earning people made that very high. Just like in the previous example, a 77-ton container makes the mean higher than almost every other container. In this article, the median income, if you line them up and pick how many, since half of them are here, if you pick the one that's just past half, when you line them up in order, then that's going to be very small, right? Maybe that was 5,000 instead of 1,000, but whatever. If half your values are 0, then the one that's in the middle is going to be your smallest non-zero thing. So then if I look through here, what can we say? The few million earning writers moved the mean atypically high. They did. I add them up and divide by how many, the mean is going to be too high. The few million earning writers moved the median atypically high. Do they change the median at all? No, just like finding the middle of the 77, doesn't matter what number this was, we're skipping it. And it doesn't matter how much the millionaires earned because we're skipping them when we find the middle anyway for the median. The many zero earning writers moved the mean atypically low. Well, they did, that's true. And they also moved the median atypically low. That's also true. So we have 3 things that are true. Which one do you think is the most dominant for what's happening?
Probably the few people that make millions moving it atypically high.
Yeah, I would say either the first or the fourth. And I think the bubbles will give you credit as correct for either the first or the fourth. And they're equally right. This one is just what's happening with the mean, and this one is just what's happening with the median. So I didn't want to say pick 2 because then everyone stresses too much. But I think you'll get correct answers for the first or fourth. Okay, questions about anything else with the typicality turn-in homework?
No.
No? Okay, if you haven't turned that in, get that in today. Bell curves. Bell curves is
Do
an
mine.
right? Because most of what we learned in the bell curves section was when you can trust bell curves and when you can't. What type of data sets actually make a bell curve, and when you do see a bell curve, when you should be very suspicious, because things like how smart people are don't naturally form bell curves. So why did it this time? So for this one, we just made one bell curve of a household electrical use for 3 years. If you wanted to see the data, there it is. So anyone need number 1 or number 2?
For number 1, I put January equals over 2000, or October and January, or I don't know. Can't read my notes then.
Okay, So
Yeah, I could.
and open this so we don't have to go back and forth. So it says either January or February, April or May, July or August, or October or November. So which one has the highest numbers?
I said
January.
January. Right. January has the big spike in 2017. February has kind of good average overall numbers. Which month has the least deviation from year to year? Remember the word deviation we used for standard deviation here. Is there lots of clumping or everyone sort of allergic to the average value? So which one has the closest clumping?
July.
July. So there's some choices there. I'm trying to make it not
I
tricky.
thought July.
So July, they're almost all the same. If someone asks, what is this household's typical monthly electrical usage? What would make a numeric answer to this question meaningful? Let's see what I'm asking. Should we say, well, what season of the year are you talking about? Or we could say, what's most common, but nothing is really representative. Or we could say, let's discard the data before December 2018. Why would we do that? In December 2018, then that would be all the blues and oranges go away. So let's just look at the kind of recent things with yellow.
The least with yellow would be August.
Tell me again, please.
It looks like the least in yellow is.
The yellows are smaller than the other ones usually. Not always, but
be August.
so for this one, I think all of them, that you can't really say what's a household's typical electrical usage. It's different if you're heating from summer to winter, right? In the winter,
All of the
you're
above.
spending more on electricity. We could look for a number that's the most common, but we shouldn't use the word representative. I'm not sure why you'd want the most common, but we could find that. And something happened. So this here, when did this family replace their old electric furnace with a modern and more efficient heat pump? So when did all the numbers suddenly get smaller?
December 2018.
December 2018. So the yellow ones are in general calmer, especially in the cold winter months.
Yeah, I answered this question before I went on to 4, and I just didn't think to go back.
So the total electrical usage in 2017 was that. The total for 2019 was that. So you could just subtract and find the difference. And then for number 6, electricity in Eugene costs an average of 11.3 cents per kilowatt hour. So take your difference you just got for number 5, multiply it by 11.3, and you can see how much money they saved. You could also write it as a percent change. Change divided by original. Is the original going to be the 2017 or the 2019 number?
17.
17, the older one, right? That's original. So for number 7, you take the change you got in number 5 and divide it by the 2017 original number. Then we shift gears a little. In Eugene, 80% of our electric power is carbon-free. So our emissions is about 16.2 grams of CO2 per kilowatt hour. So in 2019, we give you the total, multiply by this, and you'll get how many grams, and then you have to convert grams to kilograms. Those are things we haven't really talked about in Math 25, the kind of Math 20 review topics. Should we do number 8 because of grams to kilograms and things like that? I see a yes. Okay, so let's do, we have to do 7. No, we don't have to do 7. We just have to know 5 numbers. So all we want here is this number. We don't actually, we're not doing number 5. Okay, so we have 11,513 kilowatt hours, and we multiply it by 16.2 grams of CO2 per kilowatt hour. What is that? 11513 times 16.2. Okay, it doesn't ask for grams though, it asks for kilograms. So we have to change this big number of grams into a smaller number of kilograms. The trick for that was this thing with the metric prefixes, kilo, hecta, deca, the plane unit, deci, centimilla. Does that ring a bell to people? If you haven't seen it, then you take the prefixes and list them out, and often you don't need the dot dot micro. So we're just taking kilo, hecta, deca, unit, deci, centimilla. And you don't have to even write the whole thing. We just write the letters. Kilo, hecta, hecca, deca, the plane unit, deci, centa, and milla, and list them out on your paper. Then we're going from grams to kilograms. So on here, we're going from grams. Grams is in this case our plane unit. And we're going to kilograms, the prefix kilo. So this is 1, 2, 3 scoots to the left. So that means on our original number, we also go 1, 2, 3 scoots to the left. How much do you round it? Doesn't really matter. I could even do 187. Or I could do 186.5106. We have actually measured things this accurately. It's not like we're bragging with having 4 decimal places. But on the other hand, if you go in the literature, no one talks about carbon emissions with several decimal places of kilograms. They'll just say 187. So either way, it depends on if you're trying to be super accurate or just trendy. What did we do in the turn-in homework, by the way? So they rounded it. Okay. A typical gasoline automobile's emission is 8.8 kilograms per gallon. So this household has a car that gets 30 miles a gallon. How many miles would they need to drive to make as many kilograms from their car as they have from their house? You want me to do that one? I see a yes. Okay. I'm being generous with doing turn-in problems in class because, again, these aren't really about bell curves anymore. But this is good kind of stuff that's in the news, so you should see it. Okay, if you get 30 miles per gallon, and each gallon is 8.8 kilograms of CO2. So if I drive 1 mile, I get a 30th of that. So 8.8 divided by 30, I get about point. I just won't round it. So that's how much each mile is. The total we were looking for was 187. So how do I find out how many 0.293s fit in 187?
187 divided by 8.8, and then what was it?
I could use the 8.8 and the 30, but to be simple, I just sort of squished them together already. So I'll just divide by the 0.293. So we get 637.5 miles. So the moral of the story, since this is about Eugene, and these are realistic numbers, is that the carbon emission footprint that we have as people living in Eugene is very little from our house. Every time we drive 600, estimated, cars vary from car to car, but for a typical car, if we drive less than 1,000 miles, that's our entire annual carbon footprint from heating our house. So good job, EWEB, making so much of our electricity carbon neutral. The household actually drives 10,000 miles a year, which is about 333 gallons of gasoline. I would have to take this amount, this amount per gallon and multiply it by the 10,000. And then there's some division happening. So that one I will let you struggle with. If you're curious about all of this, there's websites here. You can use one website to find your own carbon footprint numbers and another one to see what's average for the Eugene Springfield area and see if your household is above or below average. Anything on the mortgages problem that you want to do? These were not due yet. The others we just did will be due at the end of the day, so turn in something if you haven't turned in anything.
We could try number 9 on more.
Number 9, okay. I'm not sure which of these numbers we'll use, but we'll kind of put them up there for now. Does having the interest rate make other numbers get half as big? So if you had a good fortuitous time and your interest rate was half of somebody else's, do you pay half as much for your mortgage, or does it not actually work that way? So let's get our amortization table. And I'm going to put a really small copy of it right up here. So for the Wall family, they had 6% and 30. So they were at 30 and 6%, and their number was $6. Might be a little hard to read, but that one is $6. For this other family, the new one, they had a table value of $4.22. We don't actually have a 4% row or a 3% row on this table to make our life easier in a math class. But of course, mortgages are cheaper than 5% sometimes, including now. So are there other numbers going to be half as much if we change the $6 to a $4.22? No. Maybe it would be if it went from 6 to 3, but we're not even starting with anything being a half. So if I went through and did the rest of the process, take the 1,100 per month, divided it by this number to see how many thousands of dollars of loan they would get, and so on, then I'm not going to get anything that's half as much. So this one is just a no. You can see that in the table if I make it bigger. As I go up in the table, if I go from, I don't have 4, so you can't really see it. Never mind. I was going to say you could look from 12 to the number up here for 4, but. Other announcement-y thing is about some MRC embedded tutoring. I'm going to pause the. Okay, questions, announcements done. So we're reviewing metric stuff a little more. We're asking how many millimeters is 2.8 centimeters. And sometimes it helps if I rewrite each thing like this. So you can really see we're starting with centimeters, we're going to millimeters. So the process again, the short efficient thing, is to write out KHD, and usually we just do U for the plane unit, DCM. If you can't remember those, make an acronym. The very traditional one is King Henry does usually drink chocolate milk, but that's not a great one, because in English you can switch the does and the usually and the sentence still makes sense, and then you might get it wrong. So The best one I have heard is Killer Hobos Dance Under Dazzling Crystal Mobiles. You can make up your own. I'll put it here on the website if you can make up a catchy saying that helps you remember the letters. But in any case, KHDUDCM, and since everything in Math 25 is open notes, this shouldn't be too hard for you to get these letters on your paper. Then we think, where am I starting? I'm starting with centimeters. Where am I ending? I'm ending with millimeters. So that is one scoot to the right. Actually, let me write that in yellow. So if that's how it is on the letters, that's how it is in the numbers also. 28 millimeters. If you haven't seen this before, then the main problem is there's too many M's. We have an M here that goes with meters. That M isn't on the red letters at all. This M is just about the milli prefix, because these letters are coming from the prefixes. And you can apply them to any measurement unit. It could be true that this M, as we have millimeters, it could be milligrams, it could be milliliters, it could be milliwatts, right? There's lots of units that we could have 1,000 of. So don't get the M for milli confused with the M for meters, and you'll be fine. There's another one. Two-part problem. First, we're asking 16 centimeters is how many meters? And then we're asking 16 centimeters is how many millimeters. So I write my letters. For the first problem, we're going from centi to plane meters. So here's the centi. Where's the plane meters?
At the end.
Now this is millimeters. So plane unit is always the U. And in this particular case, the unit is meters. In other problems, it might be grams or watts or liters or something. So we are going 1, 2, 2 to the left. So 1, 2, everyone's comfortable that there's like a decimal point hiding there. In the next problem, we're still starting at centi, but now we're going to millimeters. So this is the M for milli. So we're going 1 scoot to the right.
160.
160.
Decimal in millimeters. We just put it's 160.
Sorry, your mic cut out. Ask me again.
On the so we don't put a decimal on millimeters. We just put it 160.
Well, you could put 0.0, but 160 is fine, right? We just scoot it over so a 0 appears there. Okay, so if that's something you want to review, you can. Remember that part of your end of term test will be pick a few Math 20 things to do, like whatever it is, 3 out of 10, 4 out of 10. So this is a pretty quick one if you're good at it. If you're not good at it, don't pick this one.
Okay.
Let's look at that just in case I scared people. So at the playground's very end, Math 25 overall test, there it is, 3 out of 10 of these review things. So number 10, the metric conversion one, could be a nice quick one if you're good at this scoops. And if not, pick a different 3 out of 10. Okay, back to where we were. So health decisions we're done with. Personal finance decisions, we have done typicality and bell curves and mortgages, and we just did the percent sentences only for saving for retirement. So now we're going to move on to interest. Does anyone want some review of the percent sentences of what is and of?
What is a what?
The percent sentences had the words what is and of, and there were two ways, a translation way and a proportion way. Sounds like we should do a review problem. So
You do the translation.
I'll do both. Let's just grab a random one like you might see on the test and do both. Nope, there isn't one there. Okay, so then we go up to let's do this problem. And let's also do this problem. Okay, here we have two different comparisons to do, so I'm going to split my screen. First, I want to find 54% of 725. And then I also want to find what is 50% of 737. So the first way to do this was the translate method. I'm going to take each thing and translate it to make an equation. So what becomes y becomes equals a percent. I will use my ripflop, change it to a decimal, because that's what I can do with my calculator well. Of becomes multiply. Numbers stay numbers. On the other side, same thing. The what becomes my letter, is becomes equals. Percents I change to decimals, of I multiply. And whatever that is.
$391.50.
391.5. And the other one, 368.5. So this one is more. If you're a translate person, are you happy with what's on the board?
Yeah.
Then there was also a proportion method. The proportion method had different steps. So there's the translate method of is and what. I'm going to put this here just as a reminder. So the first step was I write the skeleton of the proportion. Fraction bar equals fraction bar. The second step, I make the percent something over 100. So 54% is 54 over 100. 50% is 50 over 100. The third step, something comes after the word of. Whatever comes after the word of goes in the bottom on the other side. So on this problem of 725, and this problem of 737. And the last step, there's something we haven't used. It could be a number. It could be the y from what. In this case, there's no y from what, so that's going in the last spot. Then I can do my cross multiplying. Remember the shortcut for this, was you multiply across the two that are not opposite y, they're opposite each other. And then divide by the odd one out. Look like division. Okay, anyone whose mind likes the proportion method have questions about the bottom of this slide?
I'm good on that.
Okay, so you don't need both methods. Pick which one. Some people like the translate method. Some people like the proportion method. Just pick one of them and be good at it.
Oh, I like the top one. I get confused with the portion one.
Let's do this one also. We have something is something percent of something. And that was this part here from our lecture yesterday. We can always write these as something is something percent of something. And the first one will become our new or change. This one is our percent, that's pretty easy. And this one is our old or our baseline. This one could be the whole, and this one is a part, something like that. So which numbers go in which spots? We want the word what, and then we want the two numbers.
The 162 pounds would go in the new chain.
The 162 is the new weight.
I'm 170.
The 172 is the old weight, and then the word what we haven't used. So what we're asking is 162 pounds is what percent of 172 pounds? Everyone happy with that one? So the only tricky part of these is this Mad Libs game, getting used to looking for what's the new thing compared to the old, or the change compared to the baseline for comparison, or the part compared to the whole. Actually doing the math is pretty foolproof now that we have calculators and so on. The process is pretty simple whether you pick one method or the other. But figuring out which things goes in which spots can be tricky. Okay, so now if we were the translate people, they would say 162 is what percent of 172? So is becomes equals, was becomes our letter, of becomes times, 172 and 162 are just numbers. Notice I didn't do anything with the percent symbol. So that's going to come back and get me later. But the percent symbol you don't translate into anything. So I have something stuck onto y with a times 172. How do I get y by itself?
Divide.
Divided by 172. And if I do it to one side, to be fair, I have to do it to the other. So 162 divided by 172, I'm getting about 0.94. And that's a good answer, but that's not quite the right answer because it asked us for a percent. So the fact we didn't translate the percent means that now we have to translate to percent.
94%.
Okay, so if you like translate method, does that part make you happy? Questions about that? No questions. Okay, so for the rest of the audience, if you like the proportion method, the steps again were fraction bar equals fraction bar. Take the percent and put it as something over 100. So in this case, okay, that's a very messy. Oh, okay. So in this case, the percent is the what? I'm not sure. What percent? So what percent? So that's going to be my y over 100. Something comes after the word of. So of 172. And the number we haven't used yet, 162. Everyone okay with my 4-step thing? Filling in my proportion if you're a proportion person? Okay, so y equals the 162 times the 100 divided by the 172. Now this is going to be different. I am just getting 94. I can simply slap a percent sign on the end. There's no riplop here. Why isn't there riplop? Because I already am doing over 100 to represent the percent. So I don't have to do a decimal point scoop twice to represent percent. Similarly, you might not have noticed in the last slide, but the translate method always has riplop at the beginning, if not at the end. Whereas this method never has riplop. If it says 50%, I just write it as 50 over 100. There's no 0.5 here. Okay, so that's our review of percent sentences. They have what, is, of, some numbers. There's two ways to do them. That's not what we want to be in. Interest, okay. To actually talk about saving for retirement, we need to talk about interest and what interest is. So you know about interest rates from credit cards and so on. If we think about it carefully, interest is a fee that the lender charges the borrower. If you are loaning money, you have a savings account, you're loaning your money to the bank. You buy a government bond, you're loaning your money to the government. Then you collect the interest. If you are borrowing money, borrowing a mortgage from a bank or borrowing with a credit card, then you have to pay the interest. And the interest is always a fee from the borrower to the lender. The initial amount of a loan is called the principal. We already saw that with mortgage loans. So how does interest work? The very simplest case is that there's a 1-year loan with a single payout at the end. So this is exactly what we did. $100 loan, it lasts a year, 12% annual interest rate, and what's the total amount paid? So we're asking, what is 12% of 100? Do it either method, you'd wind up with $12. And so ta-da, at the end of the year, you'd have to pay back your $100 principal of loan, and you'd have to pay the bank $12 for the privilege of having the loan. This kind of interest is called simple interest, because it was pretty simple. It's not true that the months interfere with each other. A slightly more complicated thing would be to say, actually let me finish the problem because I skipped over things. So this is the interest. So we have to pay back the $100 of the loan principal plus the $12 of interest. And we get 112. Wouldn't it be nice if we didn't have to do 2 steps? If we didn't have to find the interest first and then add it back on. So there is a trick for that. And the trick is called the 1+ trick. And it's saying that if we have the $100 and it goes up to some amount, let's pretend we don't know what's 112, and there's a 12% change, then I'm going to take my 100 and multiply it not by 0.12. The 0.12 is nice. The 0.12 does capture the 12% change, but we're going to multiply it by 1.12. Because that 1 is like 100%. Anything times 1 is itself, it doesn't change. So that captures the $100 of principal, so it doesn't go away. And if I do that multiplying, I get to the 112 in one step. Let's do another one with the 1 plus trick. Oops. So we have $1,000 of loan. It's going up to a certain amount. We have an 8% change. So I will take my $1,000. And what am I multiplying it by?
What?
1. That's the keep the $1,000 around times 1.
.8.
Not 0.8.
0.8.
0.8, yeah. That keeps the 8% change happening. So I'll wind up with, my brain is fried, one moment. Yeah, I don't trust myself, but okay. Okay, everyone happy with that 1 plus trick? Remember, without that 1 plus trick, the initial amount, our $100, just went away. We only had the interest, and then we had to add it back on. So this keeps it around with a times 1. Okay, so as you mentioned, in simple interest, then you have a loan and that fee, and the loan lasts a year to match how the simple interest fee works. But what if the loan wasn't 1 year?
Then we have
So now we have a 5-year loan. So it is still true that the annual interest and I will write the word simple. I probably should put it in the problem, not just the header. So the annual simple interest is 12% of 100. So 0.12, there's no $12 per year. But because there's 5 years, we have to multiply it by 5. To get $60 of overall interest. how much do they actually have to pay back? They have to pay back the 100, the loan, the principal, plus that 60 of interest. 60. And if that looks weird, it's because you don't see simple interest very much. We're used to compound interest, where each month our debt gets bigger and bigger based on how much debt we have. Whereas this times 5, it was just the same annual amount being a fee paid each year. The time we do see simple interest these days is with payday loans. So let's do one of those and it might look a little more realistic. So someone is going to get paid soon, but their water heater breaks. They need a loan right now, so they go to the payday loan store or something like that. So it is still true that our annual simple interest is going to be, which number do they write first? 20% of 2,000. But I'm not going to write a times 5 for 5 years. How will I do 200 days? What do I need to do to my 400 to say, I don't actually have to pay back all 400. I stopped my loan before that year ended.
Do we have to make it a fraction?
We do. So 200 days out of what?
365.
365 days. We don't have to pay back all 400. We just pay back a fraction of that because we were quick and paid back the loan fast. On the calculator, remember that the fraction bar is like division. So we could just have 400 times 200 divided by 365. Okay, so what is that? 400 times 200 divided by 360. So $219.18. This question only asked how much interest is due. So I'm done. I don't have to add it back on to the 2,000. If the question was different and asked what's the total amount to pay back, then I would have to combine it. Okay. That's a good stopping point. Let's look at homework before we're done. But that has moved us from percent sentences to simple interest. Simple interest used to be very popular historically because all you had to do was find the annual amount and then multiply it by how many years the loan went or what fraction of the year the loan went. The math wasn't so bad in the days before calculators and computers. Compound interest, where each month you will have more debt and the interest grows over time, earns more money for the lender. So once the technology advanced and everyone had calculators and computers, all the banks switched for almost everything to compound interest. There's just a few things like some government bonds and payday loans that are still simple interest. So our next topic will be to talk about compound interest, and this 6 years of rent increases will bridge the gap. So that's just a kind of heads up of what we're doing. There is a simple interest formula, which we'll talk about, but I don't want to try and squeeze it in just a few minutes. The formula is saying we're just multiplying things. We're multiplying the principal and the interest rate in the years, and that's what we did, right? The principal and the interest rate and how much of a year. So we'll do one of these as review next class. And then we'll say, by the way, we could write that as a formula if we wanted. And then we'll move on to compound interest. We're at the part where the pace is slowing down. Some of these topics we've just sort of whizzed through in only part of a class, but this stuff is getting pretty complicated. It will take us several days to get through the rest of this section. When I see you next, it will be week 5. You don't have in Math 25 any topic tests like the Math 20 students do. If you want to see how you're doing, then just go down to the end of the practice tests and say, I'll just try it. I'll pick 3 review problems, and we've done patterns, and we've done calories, and we've done metabolism, and we've done food scaling, and we've done cups and tablespoons, and we've done mortgages, and we've done now a simple interest. These will always say simple interest. Simple interest. And then we'll stop. So you could do up to problem 23. So if you're thinking this weekend is too sunny, you don't want to go outside, you'd rather do a math test and so on, you can do this just as a confirmation of, yeah, I'm on top of things. I can take as much of the final as I have seen so far, and that's not so bad. At the end, it gives you answers. You can look at the answers and see how you're doing. And if you do one of these and get 70% of the problems right, not all the problems, just the 23 that we're ready for, then there is an achievement about a midterm. So earn 70% on a midterm. So if you get 70% of those first 23 problems right over the weekend, I can give you a check mark on this, and you don't have to get the check mark by doing quite so well on the final or take the no calculator test. If you don't want to take a midterm this weekend, because it does seem to be nice and sunny and you have better things to do, that's fine. Just plan sometime this term. It might be good to take a practice final as your own take-home midterm.
Right.
Make sense? If you can't trust yourself not to peek at the answers, then say, I want to take one. Can you help me? And I will say, sure. And I will go to the practice tests at the bottom of the playground. And I will print out as a PDF this without the answers and email it to you. And then you can do it as a take-home thing. And then I can grade it when you send it back to me. So we can make it that formal. But if you can control yourself and not peek at the answers, then you can take the practice. It's not that big a deal. Any other questions? Oh, we should. What was your question?
Did you say that we have to go somewhere else for the test, or did you say here this weekend?
I missed the first part. Something about the weekend?
Did you say we had to go somewhere else for the test, or we can keep or do it anytime on the computer this weekend?
You can do it anytime. I'm mentioning it now just because I won't see you all the way until Monday. So it's in the playgrounds area. Scroll down to the very bottom are the practice tests, and the very last link is the Math 25 one. All the other ones are Math 20.
Okay.
So if you want to do that, it can feel good to say, yeah, you know, the class is 4 weeks done and I'm not behind. I can get a decent practice test done. But if you have other things that have to happen, that's fine too. Okay, homework. So what do the random problems for this stuff look like? There's one simple interest problem. Hey, we just saw this on the test. So we've only been 2 problems in. I wouldn't try starting the saving for retirement homework. Compound interest is a much bigger deal. We haven't talked about it at all. So for turn-in homework, then don't fall behind, turn in something. You should have all the health decisions in. If not, get those in. And turn in something today for typicality and bell curves, even if it's not 80%, at least do your best. And then if you want to try mortgages, we can, but that doesn't have a due date yet. Probably a week from today will be the due date. We'll see if we have questions about it on Monday or Tuesday. Anything else? Okay.
That's it, I think.
I'm going to stop the recording.